Hi there, the purpose of this video is to discuss the module summative assessment and explain what is expected of you and show you the data, the raw data, which you will be able to access as soon as this video goes up. So we talked about the assessment in moderate detail during your lecture or your first lecture, but here we can go through it in a bit more detail. So you will find, if you go to the Introduction to Sport and Exercise Biomechanics page, it's currently hidden but it will soon be open for you to see, these two documents. There will be more with time, but for now just the two. The first is the assessment data, that's the raw data that you will be using. The second is an example PowerPoint that we have provided just as a general guide. So, as I used to say on Blue Peter, here is one I made earlier. Here is the assessment data that you will be working with. So, as we discussed, you have information from three different athletes, athletes A, B and C. You can see here athlete A there at the top, B in the middle, C at the bottom. And the purpose of this assessment is, as we discussed, to discuss biomechanics. The long jump is somewhat irrelevant. What we really don't want is a presentation on the long jump and how the long jump is performed, even the biomechanics of the long jump. We want a presentation on what is biomechanics, really. The fact that we're using the long jump as a scenario is just so that we could put it in a sports and science, sport-based scenario. So you are given some basic data for each individual. So you're given the same information, or obviously the values are different. So this is the run-up phase here, and I've even indicated here this will require you to do linear motion calculations. The second phase is the projectile motion phase. Again, you have data for athletes A, B and C. Now this will all be looking very foreign to you at the minute, but rest assured, as the module goes on, this will become a lot clearer. And then we have the final phase, the landing phase, the phase that requires you to do angular motion calculations, and again you have data for athletes A, B and C. So, as we discussed, what are you supposed to do with this data? Well, as we go through this module, you will learn a series of calculations and equations that you can use to analyse the data. So, for example, in your lecture on linear motion, you will learn, again, here's one I prepared earlier, that linear velocity is the product of displacement divided by time. We represent this as V equals x divided by t. V for linear velocity, x for displacement, and t for time. So we are given these variables, and again some of these will make sense from what I've just said, others will not at this stage, but you've been given the acceleration of gravity. You've also been given each participant's mass. The acceleration of gravity is constant, minus 9.8 meters per second squared, and each athlete here is moving between xi and xf, and they have moved originally from the starting point at xo. Xo is not presented, it's over here. It's the start point. So at xi they are at 5 meters, and at xf they are at 10 meters. So we can deduce from that then that the starting point xo was 0 meters. You've then been given the cumulative time, and I will explain the difference between cumulative and summative time during your lecture, but we can now, with relative ease, and here is a freebie, if we just get our calculator here. So if you remember that velocity is displacement over time, and we can work out that for athlete A, their displacement at this point here, xi, we call this the initial displacement, was 5 meters. Come along, calculator. There we are. And we divide this by the time it took them to get to that point, which is 0.7 meters, seconds I should say. Then we have 7.14 now all of the numbers that are presented here are to 1 decimal place, so you too should go to 1 decimal place. You should round up to 1 decimal place, so this would be 7.1 meters per second. So there you go, there's a freebie for you. And as you progress through the module, you will be introduced to more and more equations that will help you to build on this knowledge and enable you to analyse it in far greater detail. The run-up phase questions, I would say, are the most straightforward, or equations rather. Projectile motion, a little intermediate. Once you get the hang of it, it's not too bad. The landing phase, I won't get into what all this means now, all these different variables that I've listed here. We'll save that for the lecture, which I believe you have with Stuart. But this, I would say, is the trickiest phase to attempt. Now, that doesn't mean to get the best grade you have to just do angular motion. I should add, this is the angular motion around the hip. Again, this all makes sense once you've had the lecture. If you just do the run-up phase and just decide to do linear motion equations, that's absolutely fine, but you will just need to expand on them in a bit more detail. You will need to go that little bit further in terms of discussing the various topics that comprise linear motion analysis in biomechanics. So if you decide to do more equations, that means you'll have more to present, so that will obviously mean that you still need to go into detail, but you have to be judicious about which areas you discuss in detail and which you don't. So again, it will make sense as you start to do it. So the first place to start would be very much to write down the equations. So I will introduce you to a range of equations on the next lecture that you have, which is on Thursday, and I would basically make a note of all these and then start analysing this data that you have here from each of the athletes in the run-up phase. Just start to get a feel for it, as it were. And then once we've gone through the module and you think, yeah, I think I've got enough now to present, to put together, you can start to develop your slide. Remember, the purpose of this presentation is that it's a role play assessment. Stuart and I will be playing the role of sports coaches, not biomechanists. We do not know what biomechanics is, which is kind of true in real life, but we are just in our profession, and we have employed you to perform a biomechanical analysis on our athletes, and we want to see what you found out. Not everything you calculate will have great meaning. Some will have more than others, and it's up to you to highlight that and discuss that with us. So here is my example PowerPoint. Now, it doesn't look like much, and it isn't, because it's just here as a template. You do not have to do a black and white presentation. In fact, I encourage you not to. Add a bit of colour to it, but this is just to show you the raw bones of what you should include. So title, maybe the date, your name, student number, so on. Then if you wish, you can do a brief introduction to the analysis that you're going to perform. Don't just walk in and during the assessment say, right, okay, we're just going to crack on. So I found that You need to set the scene. Again, it's a role play assessment. Imagine we've recruited you to do this analysis. We want you to, explain, just give us a little bit of background information on what you've done and what you're going to be talking about, just so that we have some idea, because again, we are playing the role of coaches. Then I would discuss the biomechanical fundamentals, most of which we covered in your very first lecture. So certainly, what is biomechanics and sport and exercise biomechanics? You can also discuss things like planes of motion, axes rotation, joint motions. That should say everything from week 1, apologies, that's week 2. That should say week 1, but you get the idea. So the idea of this is to give you at least 5 minutes before you even start talking about the data. You should easily be able to fill 5 minutes of your 20-minute presentation just talking about the fundamentals of biomechanics. From there, and again, this is just a suggestion, you don't have to do it this way, it's just a suggestion. The 2 examples I'm going to use are for linear velocity and linear acceleration. I cannot emphasize enough that you need to do more than linear velocity and acceleration to be successful in this assessment. This is just an example where I would expect someone to do, well, there's no perfect number of equations for you to do, but certainly more than 2. So don't look at this and think, oh, I've just got to do 2. You haven't. You need to do more than that. So I've decided to talk about linear velocity and linear acceleration because I want to fail, but there we are. So linear velocity, what can I do? Well, I could define it. I could explain what it is. I could tell you everything I know about it. Why is it useful to sports analysis in general and the long jump? Why would you as long jumpers, or I as long jumpers, I'm losing which person I'm talking here, the third or the first, sorry, want to know this information. The equation, don't skim over it, as I've said here. You need to demonstrate that you can apply equations like this into the real world, because that's what biomechanics is. Can you give this meaning? What does it mean? One of the best ways to do that is to use images and examples to support what you're saying. So there we are. Be careful with your units of measure, we'll get to that nearer the time. And you can discuss perhaps the distinction between speed and velocity. We touched on this on Monday. Again, these are just examples, you're not limited to this, you can obviously do more. Linear acceleration, again, define, tell us what you know about linear acceleration. Again, go through the equation, don't skim over it. And perhaps discuss the difference between acceleration and velocity, which is more meaningful in your opinion to a biomechanical analysis, and why? Why might that be? What is this based on? So again, just an example. Then I would perhaps present my results from phase 1 for all 3 athletes. So just on a table, doesn't have to be anything overly convoluted. But again, don't present, if you're going to present all of your data on one table, make sure you highlight key pieces of information, otherwise it's just a wall of numbers, which to a long jump coach might not make any sense. So you need to emphasize what's important, what isn't, and explain why. I would suggest doing or discussing a few biomechanical variables at a time, presenting them in your results, and then discussing a few more. So these are 2 equations that we use in kinematics. I would then perhaps follow this up after I presented the results by discussing linear force, which is kinetics, and impulse maybe. And finally, if you do use any references, you need to reference them at the end in your final slide. I never know how to answer the question, how many references should we use? You use as many as you need. Make sure, again, referencing is part of your grade, so don't just skip over this. We don't want to see any websites in there. 1 or 2 books max. You may choose to use a few research articles, but it's entirely up to you. So just to recap then, my advice would be do the mathematics first, create your presentation, and once you've got to the stage where you think you've got 20 minutes worth of content there to discuss, and that might seem daunting, 20 minutes, but trust me, it flies by. And when you think how many hours myself and Stuart will be talking to you for throughout this module, you've just got to condense and distill some of that down to a 20-minute talk. It can be done. So don't be daunted by the time is what I'm getting at. So the next thing to do, once you think I've got 20 minutes worth of content here to talk about, is to practice your presentation. And the more you practice, the better it will be. I would suggest practicing at least 10 times in the build-up to your assessment. Starting off practicing regularly, and actually practicing less the more you get towards the assessment deadline. Panic revision never works for anyone. So there we are. I hope that's helpful. I think I've covered everything. I've got this huge list next to me of things I needed to talk about. I think that's everything. Again, and as always, if you have any questions, do feel free to email myself and or Stuart, and we'll get back to you as quickly as we can.